we get started, we'll just have a quick recap of the last class. So, Tejal, could you just do you recall what all we had learned in the last class? We went through what are nonlinear equations. Then, yeah, you can go ahead. You can tell.
Yes, ma'am. We learned about the types of functions like algebraic functions and non-algebraic functions.
Mm-hmm.
Then what are polynomials?
Right. Okay.
Then we also talked about what are the roots of the equation and why do we
Exactly.
need to find the roots of the equation.
Excellent, excellent. So that is a very conceptual idea that what are the roots and why do we at all need to find the roots. Okay, so that was one of the concepts that we went through. Roots. So what are the roots and why do we need to find the roots? Okay, and after we understood that why are we finding roots, we went ahead and learned two different techniques to find out the roots. So they were, one of them was bisection method and the other was secant
Secant
method.
method.
Okay, so this is all we had learned in the previous class, and let's see what we are learning today. Okay, so for today's class I have kept four topics. That is, we'll be learning fixed point iterations, so starting with what happens in the case of single variable fixed point iterations, and then what happens in multivariable fixed point iterations. Okay, so from the concept of fixed point iterations, we will move ahead to Newton Raphson, which is a modification or in the same line as secant method itself. So then we learn the Newton Raphson method again in a single variable and in multivariable. Okay, so we'll get started. So before we get started, we'll have a quick recap of again the main motivation of the class. That is, why are we at all finding the roots? So Tejal, would you like to just give an idea or summarize as to what you have understood, that why are we finding these roots?
Because we need to find some parameters like last time we had taken some example related to parachute.
Exactly.
So we had to find the parameters C and M.
Exactly. Right. So that's very good. I'll just put it together. All you said is very correct. So, what are we trying to do here is basically whenever we are trying to study a system, that system can be written, can be sort of encapsulated in the form of an equation. Okay, so the equation that we were studying last time was something around this line, that the velocity of the parachute depends on the acceleration, mass, and the what was C last class? um, you remember what C stands for?
Drag
Drag
coefficient.
coefficient, right? Gm by C into some expression. Okay, 1 to e to the power some function times t. Okay, suppose this is the equation which basically represents the physics of a system. Okay, so now what we were trying to do here is that, given the velocity of the parachute and given the amount of time it had taken to attain that velocity, we were trying to find out what all will be these parameters. That is, one we were trying to find out was the drag coefficient. Okay, so in order to write this expression to find out this value of C, we rearranged this whole equation and we wrote it something around this line, that this entire function can be written as a function of C, in which the RHS can be written as it is right now, but the LHS can be subtracted and written in this form, and the entire expression could be equated to 0. Okay, so our main motivation to find roots is basically to solve this expression f of C is equal to 0, and for what values of C is this f of C equal to 0. Okay, so it ultimately goes back to the main idea that we are trying to study a system. Okay, any system. So with that, recap of the main motivation again, we will go ahead and see what are the techniques that we are going to learn today. That is, again, in order to solve these non-linear equations, we use these numerical solutions. That is, one of the method is known as the bracketing technique or bracketing methods, and the other is known as open methods. The main idea of bracketing method is that we select a bracket around the root and we try and merge towards the root. And the main idea of open methods is that we just have one single initial guess, and with that, with the help of that initial guess, we go either converge or diverge from the root. Okay. So in today's class, we'll be learning about these two techniques. That is, one is fixed point iteration and the other is Newton's method, Newton Raphson method. Okay. So we'll get started with what is fixed point iteration. Okay. So fixed point iteration is also otherwise known as successive substitution. If you read the book, the S.K. Gupta book that is recommended for this particular course, or even Ramin S. Fandiari, if you read this book, they have used these terms interchangeably, that it is either fixed point method or successive substitution. Okay. So, as we know that this fixed point iteration or fixed point method is an open method to find out fx equal to 0. So basically, with the help of the single initial guess, we are trying to find out converge or diverge from the root. Okay. So let's try and understand step by step what is happening in this fixed point iteration method. Okay. So let's go through the algorithm once. What we do is, when we are given a function like fx equal to 0, just now the example we were seeing, it was written in terms of fc is equal to 0. Okay, so let's try and have a function which is written in the form of fx equal to 0. The first step, what we do in fixed point iteration, is to recast. The technical word used here is recasting the equation. We recast this equation and try and write it down in different possible formats. Okay, so here it will be a bit tricky to understand what is recast, why are we writing it in this way, and so on and so forth. But once I take you through the entire algorithm, you'll get an idea. Okay, what are we doing here? So imagine the function fx equal to 0, and that function may have some form like, it may be like x square plus 3x plus 1. Okay, suppose this is the function. So what you basically do is identify any x. Either you take this x or x square, may say this x, and you rearrange this expression and you divide, you just take the remaining terms on the other side of the equality sign. Okay, and you just write it in terms of x is equal to some other function g of x. Okay. Now, this is known as an iterative function, iteration function, and there you can identify two sets of functions. The one that you have written on the LHS, that is the one x that you have separated out, is the one of the functions a or b, and the other, whatever is remaining on the other side of the equality sign, is the other function a or b. Okay. It might be a little confusing for now, Tejal, but we'll go ahead. I'll ask you if you have any confusion later. Okay. So the second point over here is that we try. Yeah, are you saying something? Okay. Okay. The second point in this algorithm. Okay. The second point in this algorithm is that we try and find a point of intersection of these two functions. Okay. So once you have identified two functions, that is, this side is one function and this side is one function, when you have identified these two functions, you just write it, break it down and write it y equal to g of x and y equal to x. Okay, these are your two functions. So you go ahead and find the point of intersection of these two functions. Okay. So Tejal, can you quickly tell me why are we interested in finding this point of intersection of these two functions?
To get the root of the function f of x.
Excellent, excellent. Very good understanding. So the point of intersection basically gives you the root, basically gives you fx equal to 0. Okay, and fx is something which you had rearranged and written as g of x plus x and all of these. And finally, when you merge these two functions, wherever they intersect will basically give you the roots. Okay, so that's an excellent understanding that you are finding the point of intersection, because that is what will give you the roots. Okay. So when you intersect these two graphs, the fixed point that you will get of any of the functions is ultimately your root. Okay, and because this iterative method starts with that one fixed point where the where the two graphs have intersected, it has got its name in that way that it is a fixed point iteration. The initial guess that we take lies somewhere close to this fixed initial point, okay, fixed point that is got by the intersection of the two graphs. Okay, I'll tell you more about what is the initial guess, how do we get it, and all of that. The third step is that this procedure basically begins with that one initial guess which will be given to us in the question, and it lies somewhere close, somewhere near the fixed point. Okay, and the next point, that is x2 and ultimately xn, which will be your root, will basically be found out by substituting that previous x that you had predicted close to that fixed point. You evaluate and you get the answer of g of x1, so you get x2. Now that you have got x2, you go ahead and find out x3 and so on and so forth. Okay, so that was not meant to be shown to you, the bottom part of the slide. Okay, so I want to take you through this concept of recasting. Okay, so have you come across this concept of recasting, Tejal?
No, ma'am.
Okay, so can you just understand, like from how I explained in the the last few minutes, no, that an expression, a function will be given to you, and you rearrange it. You take out the x and you rearrange it in different formats. Okay, so can you tell me some different forms in which this function can be rearranged and written? Just take x to one side. Take one x to one side and keep all others to other side. Can you try and tell me a few ways?
Yes, ma'am. So we can write x square plus 1 divided by 4 is equal to x.
X square plus 1, so that remains on this side. 4x goes to the other side, and hence divided by 4 will be equal to x. Okay, this is one of the ways in which it can be recasted. The other way,
Yes, ma'am. X is equal to square root of 4x minus 1.
x is equal to square root of 4x minus 1. So you
Minus 1.
basically, yes, you basically keep this on this side and you take it as 4x goes the other side, minus 1 and square root. Okay, just like you have recasted this expression in these two formats, there can be a number of ways in which it can be recasted. Okay, let's try and see a third possibility. A third possibility can be something like x square plus 1 can remain this side and 4x can go the other side. Okay, so x square plus 1 minus 3x equal to x can also be another possibility. Do you agree with
Yes,
me,
ma'am.
Tejal? So, do you get the basic idea what's happening here? That whatever function, oh god, sorry. Okay. So, whatever function is given to you as the question, our basic idea, I just need to increase it. Okay. So, whatever function is given to us in the question, our main point is to just take x on one side, keep x on one side, and find out what are the ways in which it can be rearranged and written. In technical terms, this is called as the concept of recasting. Okay, you're recasting your main expression, main function that is given to you, taking out x on one side and writing whatever is remaining on the other side of the equality sign. Why taking out x is something I will ask you only, and you will be able to answer after a while. Okay, so just like 1, 2, 3 ways I have recasted, the fourth way you had already mentioned, this is one more way. If you agree that x can also be written as 4 minus 1 by x. If you rearrange it and write, you will get back this expression. Okay. So now, Tejal, the idea of recasting in fixed point iteration is that once we recast these functions in a particular manner, and we start with an initial guess. If you remember in the initial classes, I said that this initial guess is given to us in the question. Okay, so whatever initial guess will be given to us in the question, or when we are solving a project, a PhD problem, or any project, so that time we take an educated guess of these initial guesses and so on and so forth. So whatever initial guess we substitute and we find the next iterative value of the root or the x, which is here called as x. So it either diverges or converges towards or away from the root respectively. Okay. So you will understand the importance of recasting in a particular way by getting the answer of x, and if you see it diverges from the root and it converges towards the root, and that is how we'll be able to understand that this is the proper way of recasting and the other is not. Okay. Did you get the idea slightly, Tejal? Would you like to take a break here and just talk, discuss anything?
Yes, ma'am, I understood that we might get to the solution or we might not get to the solution.
Exactly, correct. So based on that, you are going to recast in a particular way. Okay, here I've shown you how many. 1, 2, 1, 2, 3, 4 is the same thing. This is the fifth. 1, 2, 3, 4 only. Okay. So 4 ways I've shown you how you can recast this. This and this is the same. So there can be other methods as well. Okay. So now let's go ahead and take an example and understand how this is done step by step. Okay. So if our the function, let's take a general form of the function, that is f of x equal to 0. And let's take a specific example, that is let the function be in the form of x minus 1 by 3 e to the power x equal to 0. Okay. So our first step is to recast. Okay, so do you agree that this is one way, these are the two ways in which it can be recasted? This is one, x equal to 1 by 3 e to the power x, you just take it on the right hand side, and the other is you rearrange x in such a way that ultimately you will get back to this. So do you are you able to understand this the ways in which it is recasted, type A and type B?
Yes, ma'am.
Okay, so the first step is to recast. Okay, we will go to the graphical concept first. I'll take you to the algorithm a little bit. Now the second step is to use the initial guess that is given to you in the question. In this case, the initial guess given was 1.25 for the value of x. What you basically go ahead and do is find the second iteration of x. Okay, you just place this value for type A in this x place, you just keep 1.25 and you get the value for second iterative value of x. And similarly for the type B, you again place 1.25 and get the second iterative value of x. Okay. And here for the benefit of explaining you, I'm truncating this at truncating, not rounding up, truncating this at the third place of decimal. Okay. Now, similarly, you go on proceeding with all these iterations. Okay. Here I will take a break and come to the graphical concept. What is happening in the graph? So, if you look at this function x minus 1 by 3 e to the power x equal to 0, if you look at this function basically takes the form as this particular curve that you can see here. Okay. So, Tejal, can you quickly, this is just for understanding, for other viewers who will view it later and for our understanding, that is this particular function, that is x minus 1 by 3 e to the power x equal to 0, uh, is drawn in this particular way on the curve, and this point is basically giving us the roots. Why are these points called the roots? Can you just tell me quickly?
Because when we put these values in the equation, it will give y is equal to 0.
Yes, that is fantastic. That is like a direct understanding of the expression. But I just want you to answer in terms of the functions that you are seeing. Again, there are two functions that we are able to see. So one function is the LHS, and what is this function RHS?
Y is equal to 0.
Excellent. So y is equal to 0. The value of the function in which y is equal to 0, or this function can be written in terms of g of x, where the function is given as y is equal to 0, is the second function. And when we are equating the two, we are basically trying to find out the point of intersection of these two functions, where your function a is this and your function b is this, and wherever it intersects is the root. I am trying to emphasize on this concept again and again because there always stays a misconception, that is, roots can only be found out where it is intersecting the x-axis. No, it is not where it is only intersecting the x-axis. It is wherever it is intersecting the function. Here the function is g of x, which is given by y is equal to 0, and hence the root is found out by the intersection of this curve A with the x-axis. This idea is clear, right, Tejal? You have understood this.
Yes, ma'am.
Excellent. Okay, so the main point that I was going to emphasize, I'll just clear these things. Okay. So I will, okay, I'll just write for the benefit of others. This line is y is equal to g0. This can be written as g of x. Okay. Okay. So here you can see that wherever it intersects the x-axis, that is the two roots, the value of the roots are given as 0.619 and 1.512. Okay. So as we were performing the iterations here, till the third iteration we had discussed. If we go ahead till the 20th iteration, you see that it converges to the roots. Okay. This one form, the type A form that we had taken when we recasted in this manner, this converged to only one root, that is 0.619. And when it was recasted in this manner, that also converged to only one root, that is 1.512. Okay. And this happened when you started with the initial guess of 1.25. Okay. Now, so what is your observation? What is the take home message from this technique that we have got so far? That is, when we start with a particular initial guess, that is x1 is equal to 1.25, and we have recasted in two different formats, A and B, we A converge to root 1, that was 0.619, and when we recasted as B, it converged to the root 2, which was 1.512. Okay? Now let's see the importance of selecting this initial guess very precisely, and what happens if the initial guess sort of is changed. So we had done with 1.25, right? Let's go ahead and try with 1.75 now. Okay. 1.75, again the type of recast remains the same, type A and type B, where it was this 1 by 3 e to the power x, and this was 2x minus 1 by 3 e to the power x. Okay. Here you will see. Okay, what are your okay? So what are your observations, Tejal, on this? What is happening when the initial value is changed? What is happening in type A and type B? Any guesses?
With respect to time B, we are getting to the solution, but with respect to type A, we are not able to reach to root 1.
Exactly. Okay. So in technical terms, what this is called as? In this, the root is diverging. Okay. Here we are converging towards the root. Okay. Now, so the observation that happens that comes here is that when we have changed the initial guess and it is recasted in form A and form B, form A, when the initial guess was 1.75, the root has diverged, and in form B it has converged. Okay. So the conclusion here is that the convergence, that is, you're finding the root, right? So you basically need to go towards the root. So going towards the root and merging with the root is called convergence. Now, convergence depends on two factors. That is, one is the choice of f of x that you have taken. Choice of f of x in the sense the way you have recasted it. Okay. That determines the convergence, and also the initial estimate determines the convergence. Okay. So, Tejal, any doubts so far? Anything you want to discuss or any concerns?
What do we mean by order of convergence?
Order of convergence. Okay. Sir had discussed this in the class.
Now we had used that term, but I didn't understand what does it mean.
Okay, so upon order of convergence, no, I will make up a separate tutorial and I'll get back to you, because I have not prepared that for today, and I also am not totally clear with the concept. So I will do it
Okay.
properly and I will get back to you. Okay? Either you write it to me on this thing on the doubt forum, or let me see, next class I will cover order of convergence. Okay? I also have to go through it once. I
Okay.
also don't remember exactly what is the order of convergence. Okay? So I
Yes,
will
ma'am.
just write it here, order of convergence. Okay, I will go through it and try and solve it in the next class. Okay. Okay, any other doubts from what we discussed or any confusion, anything?
No, ma'am.
Okay. So now let's go ahead and get a graphical understanding of what we have done so far. Okay. Basic, we in this graphical understanding interpretation, we will try and understand what is happening when we are recasting the equation. Okay, you have understood the concept of recasting, right, Tejal, so far?
Yes, ma'am.
Excellent. Okay. So, can you tell me here? I have kept this page blank so far. So, here we will have a discussion. So, can you tell me what is happening? Suppose this was the type A, right, where we had recasted the equation in the form of x is equal to 1 by 3 e to the power x. Okay. So, when you see this particular equation in this format, x equal to 1 by e to the power x, can you plot it like, do you have any understanding of how the plot is supposed to be? For your benefit, what I will do is I will give you one of the plots. I will draw this. Okay. Okay. So for e to the power x, I will draw the curve. It will go something like this. So I'll draw the curve and give you 1 by 3 e to the power x will have a general form like this. Okay. So can you now tell me how will you plot this thing? It's a conceptual thing. Okay. It's not about memorizing. It's only your understanding I'm trying to test here. So do you have an idea how would you plot x equal to 1 by 3 to the power x?
Yes, ma'am. We'll draw a y equal to x line with slope 1,
Right.
and it will intersect this curve
Right.
at some points.
Right. So you will draw the curve y is equal to x, right? So just one, for the benefit of the viewers, whoever will see this later. So why are we drawing this line y is equal to x? And like, how are you able to understand? How are you able to come to the conclusion? It's just given to you x equal to 1 by 3 e to the power x, right? So I have drawn 1 by 3 e to the power x for now. So how will the students understand that they have to draw this line y is equal to x? Any clarification on that? You're going right. You're perfectly correct. So tell me.
So, ma'am, LHS is one function and RHS is another function, and we are trying to find out the point of intersection of these two functions.
Excellent, excellent. So, very good, Teja. I'm very impressed. Okay, so for the benefit of everyone, I'll just say that whenever we are given an equation like this, our first goal will be to identify two different functions. Okay, so this is function 1 and this is function 2. Okay, and let's write it down. Why am I writing it again? It's already here, so I will take you through this only. So whenever we are given a function like this, we are going to identify two functions and write it. So your first function can be written as this. This is your what? This is your RHS, right? So I will write the RHS here. So that can be written as the first function y1 is equal to 1 by 3 e to the power x, and the second function, this would be your second function, which is the LHS, can be written as y2 is equal to x. Okay. Now, when you have identified the two functions, your aim is to basically find out their point of intersection. And why are we finding the point of intersection? Those will give us the roots of the original function. This is the recasted form, but it will give us the roots of the original function. Okay? Now, let's go ahead and understand what is basically happening when we are, given the initial guess and we substitute it and get the next value of x and so on and so forth. This is just calculation, right? So what is happening in terms of graph? Let us understand. Okay. So our step 1 was to plot the two functions. Our first step was to plot y1 equal to 1 by 3 e to the power x, and our second was to plot y equal to x. Okay. So these are the two functions plotted. Now what we will do is we will take an initial guess as given in the question for now is the start from point A. Okay. So we will see three cases here. Case 1 we will see when we are starting with point A. Case 2 we will see Case 1 we will see when you're starting from point A. Case 2 we will see when you're starting from point A dash, this one. And case 3 we will see when we are starting from point A double dash. A double dash. Okay. And I will just erase what is not required. This and this, this and this is fine. Okay. Okay. So let's start with case 1. Okay. So we have started with the point A, and that value of x was 1.25. So now what we do is we go from A to the curve this 1 by 3 e to the power x, and from that point we go and find out what is the point, what is the y coordinate at that point. Okay, so the x coordinate was 1.25 comma, if we extend this line in this direction we will go ahead and find out what was the y point, right? This one basically. So we will write down that value of y. For now I will just give it as y1. Okay, why we have done that? Because we, with that value of y, we come back to the other function, we come back, we trace back, we come back to this other function. I'll zoom in for your benefit. Okay, we come back to this other function, and then we identify for that value of y1 what is the value of x. Okay, so that is basically your second iterative value of x. When we put in the value of x, first iterative value of x1, and we solved the expression and we got x2, graphically what we have basically done is taken that x1 value, gone to our first curve, onto the y-axis, traced that value of y, come back to this, we came back to the other function, then traced back to the x-axis and found out x2. Okay, so this value is basically your second iterative value of x, that is 1.06. Again we repeat this process, we go from x2 to the curve, we reach till here, we then again go to the y-axis till here, we come back and get a particular value of x which solves this particular point, and we go on repeating. Okay, ultimately now so far what I have been telling you is traveling from the x-axis, from this x-axis to the y-axis, back to x-axis, back to y-axis is what I have been telling you, right? So ultimately let's understand what we are doing. Ultimately now you can just focus on this area. Okay, so what we do is when we have that value of x, the first iteration, we were here, right? I will now keep highlighting, we were at this point. From this point we have gone to, when you basically go to the y-axis, what you're doing is you're coming to the other curve. Okay, once you are here you identify that point and then get the value of x2. Getting the value of x2 basically means now you have reached this point of the other function. Once you come at x2, you extend that value to y and you come at this function. So ultimately if you see stepwise you are converging towards the root. So from that point you go ahead and come here, then here, then here, then here, then ultimately you are at the root. Okay, similarly, if we take another example, imagine you have started at this point. You know that one of your roots is 0.619. You've started at this point. You go and intersect at this particular line, reach one of the functions, and understand what is the value of y. For that value of y, you cut the other function and identify what is the value of x. For that value of x, you extend and cut the other function and identify what is the value of y. For that value of y, again you cut the other function and extend below, find the value of x. Again similarly what you end up doing is converge towards the root. Okay, but one final example, let us see. What if you would have started, we know that this is also one of the roots, 1.512. So what if we had started at a point a double dash, we had started at something around what we can do, 1.7 maybe. Okay, so see now what is happening. Our first goal is what? To go and cut the first function, the curve. Okay, so we come and cut the function here. So for that we identify the value of y, we extend till the y-axis, identify the value of y. For that value of y we find out x. that x value, when we try to come and cut the other function, we see that it is not converging towards the root anymore. You can see here from this diagram that it is constantly diverging. If you would have drawn these functions, extended these functions, then these would have constantly diverged. Okay, so this is what is happening when we are doing the calculation. So as a recap, let's see. When we have the first initial guess x1, with that, what we initial guess here in this case was 1.25. With that, what do we basically do is we go to one of the functions and identify the value of y. With that value of y, we go and cut the other function and identify for that value of y what is the second iterative value of x. We repeat this entire process till x3, and then we continue unless and until we find we converge at the root and get our answer. Okay. So this is what we have been doing, comparing the calculation and the graphical method. So any doubts, Tejal? Anything you want to discuss or anything?
No, ma'am. Now it's actually clear what the method was.
Exactly. So you would like to just, comment anything, just talk out your thoughts. I mean, what are you thinking? What you used to think before, and now what are you thinking? You can tell me.
First, I used to think that we are doing x is equal to g of x, and then we are using the value, previous value of g of x for calculating the new x. But I was confused why it is giving the solution. But now, seeing the graphical picture, I understood how it's giving the solution.
How it is giving the solution. So, Tejal, because you raised this point, there's also one more interesting point that I can tell you is that, are you realizing? I mean, in the calculation we saw when I showed you that till 20th iteration it is converging only to one root. Okay, so so there also a question can come that I'll take you to that place. Wait. See, let's be here. Okay. Okay, so we had recasted it in type of, sorry, we had recasted it in type A and in type B. Okay, when we recasted in type A, we were getting 0.619. It was one of the roots. Recasted in type B, we were getting the other root. Okay, so do you realize that when we recast in a particular fashion, that is 1 by 3 e to the power x, and we have a particular initial guess, it is only giving us one root. It is not giving us the other root. Do you acknowledge this factor? Do you
Yes,
understand?
ma'am.
Now, here also one question one can ask, that why is it only coming up to this one root? What about the other root? How can we reach the other root then? Okay. Because the graph that we just now saw was for this, na? We were seeing the graph for x equal to 1 by 3 to the power x. है ना? We did not see the graph for this, right? Now, if the question here is that, what about the other root? What about the other root? Okay, think about this. But to answer this, one very clear and convincing diagram would be this, where you can understand that if your one of the roots is 0.619, this is one root and this is one root, and you start at an initial guess of 1.25, and you reach here from, okay, just a minute. Okay, so yeah, so if one of your the initial guess that you had started with was 1.25, and you reach the point here in the graph, so can you understand that you are converging only from here? Which direction are you going? You are only converging to this route. Are you able to, visualize that, Tejal, in this diagram?
Yes, ma'am.
So, likewise, in the calculation, it was not understood. Calculation was very black and white. It just gave me one value that was 0.619. But now you tell me, this when I am at this 1.25, here I am not able to move in this direction. If you go in this manner, if you go and cut this particular equation first and then proceed, you're only able to move in one direction. Similarly, when you take the other one, when you take, suppose your initial guess as this, you are not moving in this direction, you are moving in that direction. So it will only converge to one single root, okay, and not the other one. So this is the graphical representation of the fixed point technique. Once I'll remove all this, okay, of the fixed point technique. And now we will move on to the multivariable fixed point technique. So hi Leesh, can you just spell out your name?
Good afternoon, ma'am.
Good afternoon.
Myself, Lilesh Hirki.
Yes, okay, hi. So I'll just continue from here, Lilesh, from multivariable fixed point technique. But can you, like, whichever part I explained so far, can you go through the recording and get back to me if you have any doubts? Okay, because I have time constraints, right? So will that be okay?
Okay, ma'am.
Okay, you get back to me. Get
Yes,
back to
ma'am,
me
it will
in the
be.
doubt forum. I will answer all your questions. Okay.
Yes,
Okay.
ma'am, yes, ma'am.
So I'll move ahead to the multivariable fixed point iteration. So what is happening in case of multivariable is that so far what we have been seeing were the function in just one variable, right? The only one variable we were talking about was x, okay? Now obviously it may happen that the function you're trying to study or the system you're trying to study only does not depend on x. It depends on x1, x2, x3 and a lot of other variables, okay? In that case we are supposed to use multivariable functions. So what happens in case of multivariable functions is that you again have a concept of recasting here. It is very similar to the single variable. So if you, Tejul, if you've understood the single variable well and after Leelesh you go through the single variable once, this multivariable will be simple enough. Okay? So in this case, what you basically do
Yes,
is,
ma'am.
okay. So in this case, what you basically do is you again, just like we had recasted x in single variable form. Okay, what happened? Okay, I don't know what happened. Okay, sorry. So just like we had recasted x equal to f of x in the same manner, here how will we do the recasting? We'll just have a vector form, okay? It just won't be one variable. Since there are many variables, it will be x1, x2, x3 and so on. How many ever variables will be there, and be recasted in the form of f1, f2, f3 with the help of all those values of multivariables that are there. So x bar basically stands for x1, x2, x3 and all the other variables, okay? So I will just take one small example of the multivariable and basically talk to you about the algorithm. Okay, I'm not going to solve it here. If you want to see the solution and how it is solved, you can refer to this book, S.K. Gupta. Okay, also we have less time. We just have 10 minutes. I'll try how much I can. Okay. So what will happen here is that suppose we have these two functions, f1 and f2. Why two functions? Because here we have two unknowns, right? So two unknowns, two different equations. So in these two equations, let's see how do we proceed. So this is given to us as the final solution, like the roots of the equation, okay? And our initial guess is given to us as 0.5, 0.5. So it means that we start with the value of 0.5. Okay? So the algorithm says that when we are given these two functions and we are given the initial guess, what we are basically supposed to do to find out the next iterative value of y bar, is that we will be using the initial guesses given to us for x2 and for x3, substitute those values in this particular function, this function and in this function, and get the value for the vector. Okay. Similarly, again for the other function, for finding out y3, so there is one small understanding here, that is, see, this was your equation 1 and this was your equation 2, right? So I told you there are two unknowns, two equations. So from equation 1, we will try and concentrate on one variable, that is x2. And from equation 2, we will concentrate on one variable, that is y2 and y3. If we had another equation, we would concentrate on probably y4. Okay. So using each equation at a time, we will recast and rearrange and write y2, y3, y4 and all so on and so forth. And when we recast, our LHS will be just one variable, right? Like how in the single variable it was just x. In this, it will be y2, y3, y4 and so on. The RHS will consist of whatever remaining is there. So in the maximum case, I'm considering let all of them be there. Let y2, y3, all of them be there. Okay. So your RHS will basically comprise of the rearranged form, of this particular equation, and the value of y that you will be putting here will come from your initial guess, that is 0.5 and 0.5. Okay. Similarly, for the other variable also you will do the same, and you will get the answer for f1 of y and f2 of y bar. Okay, f1 of y bar and f2 of y bar, and you keep repeating this till an extent that finally you converge at the solution of y bar. So did you understand this? I mean, this is complete photocopy of the single variable, but just that you have a few more variables. That's it. Is there any doubt, confusion in this method? Tejal, Leelesh, anyone?
No, ma'am.
Okay, you just go through this. I'll
No,
just
ma'am.
okay, okay, just go through this because it's just a photocopy of the single one, and get back to me right in the doubt forum. Then I'll see if I can, explain your doubts better. Okay, so this was just one example in which I had written down the answer where to appreciate the fact and the importance of recasting. Okay, if those equations that I had written above in this multivariable format, if they were recasted in type A or in type B, you see that with the same initial guess of 0.5 and 0.5, in one particular type, it is completely diverging. That is, the solution is supposed to converge at 0.6 and 0.4. In one particular recasted format, it's completely diverging, and other recasted format, it is converging. Okay. So this is the importance of recasting, and you get back to me if you have any doubts on fixed point. Okay. The last 10 minutes, I will just get started with Newton Raphson because the concept is beautiful and I want to, convey this to you all. Okay. Probably we'll get late by a few minutes, 5 minutes. Will that be okay for both of you? We'll try to finish in 10 minutes.
Yes, ma'am.
Okay. Okay.
Yes, ma'am.
Okay. So let's start with the Newton-Raphson method. The Newton-Raphson method, if you all have seen my last video on secant method, is a very similar method. And it's just different from the fixed point iteration. Okay. So this is again another open method to find out the roots. And in this case, one fact is stated, that is whichever function we are trying to find out now, whosever root we are trying to find out, the derivative of that function is supposed to be a continuous function. Okay. And you guys think about it. I would have discussed with you all, but now there's no time. It's just 10 minutes left. So you guys think about it and come up. I will ask you in the next class that why do you think that this f dash x is supposed to be a continuous function? Okay. So let's go ahead and understand what is happening in the Newton-Raphson method. So in this case, we will see the graphical interpretation and the algorithm at the same time. Okay, it's easier to understand it this way. Okay, so let's see. We are trying to find out the root of this black line, this function, this black line, which is given as f of x. Okay. Now what we will do is we will take one initial guess which will be initially given to us in the question. We will take this initial guess, and with the help of this initial guess we will go ahead towards the graph, towards our function f of x, and cut it at a point, okay, wherever it is cutting. At that point we will draw this tangent that you can see in the orange color that I have drawn, this tangent, this straight line from this point to this point. We will draw this tangent, and when we draw this tangent, this is going to cut the x-axis at a particular point, x2. Okay. And once we reach this particular point, x2, we will go ahead and write the value or find out the value of this x-intercept. Okay. Here I need to have a discussion, otherwise we will not understand the concept. So can both of you or any of you just unmute and tell me, why are we finding the x-intercept? What is the, like, why? I'm just trying to, train you guys in such a way that whatever you do, even in maths, ask why. So why are we interested in finding the x-intercept? Anyone?
Ma'am, to find roots, real roots.
To find real roots. That's excellent. So, Lilesh, any idea here? Now tell me, here we have come just to x2, right? And x2 is not the root. So, what is the concept behind finding this x-intercept? How will we understand? It is just an algorithm given in the textbook, and it's just stated that you connect to the x point, you cut the graph there, and then you extend it and find x intercept. Okay, and that is your x2. But why is it your x2? Any other idea? Tejal, would you like to answer? You're correct, Leelesh. You're completely correct. But I just want to know what is your understanding? Yeah, Tejal.
From tangent means we are trying to find the derivative at that point.
Okay. So what will happen if we find the derivative at that point? That is coming, Tejal, but the point that you are saying, it's coming in the next point. The next Y homework I've written, no? That is the question that I'll ask you there. But right now I'm asking you the idea of why yet. Are you able to understand the question? Is it a sensible question? You first tell me that. Like, are we allowed to ask this question? That not allowed to, as in, is it a good question to ask? That why do we need to find x intercept? Do you guys acknowledge this fact?
Yes, ma'am.
Yeah. So it's
Yes,
okay.
ma'am.
Yeah. So it's okay. So I'll give you the idea. Okay. So that is the entire crux of this system. So I'll give you the idea. So Leelish, as you said, very correct. The x-intercept we are trying to find out because we want to get to the root. Okay. But if we answer this, anybody can ask, but right now we are not at the root. So how does this x-intercept even help us to find the root? Okay. The answer lies in this very simple concept that is why all these are called iterative methods. Right now we are not at the root, but after finding the x-intercept, the way we proceed on in this method, ultimately we will go and find the root. Okay. So we need to understand what is happening graphically when we find the x-intercept. Now you see, we have drawn this orange line and we have got the value of x2. Okay. From x2, again what we will do is we will go and cut the curve wherever it intersects, like whichever that the point whose x coordinate is x2 and the y coordinate is something. I'm not writing that, and y coordinate is something. Okay. Again at that point, what we will do is we will take this tangent and again cut at the x-axis. Once we reach at this point, I will zoom in here. Once we reach again at this point, I will take another color. Okay. Once we reach again at this point, we'll again go and cut wherever it intersects intersects in the sense whichever is the point on the curve where the x coordinate is x3. From that point, we will again draw the tangent. Very bad tangent. We will again draw the tangent and we will cut at a particular point. Okay, that will be your x4. Now, from x4 again we will go cut a curve, and ultimately you will realize that we have converged to the root. Okay. Now the point of the idea of x-intercept basically comes when you are writing the equation of the tangent. Okay. So here I have written the algorithm for you that you have x1 and you have found out the point x1 and fx1 on the graph, and you have plotted the tangent, drawn the tangent. From the tangent you have gone ahead and found out the x-intercept. When you found the x-intercept, that value was x2. From x2 you have again identified the point x2 and f of x2 and drawn the next tangent. But okay, before that you have written the equation of the tangent. Okay. So let's see what is happening when we write the equation of the tangent. So if this is the tangent whose equation we are trying to write, if this is the tangent whose equation we are trying to write, can you both tell me what will be the equation? It's no doubt written here, but still. So let us take 2 points. That is let one point be x1 f of x1 and the other point be x2 and y. Okay, some value of y. So can you tell me, or do you agree that this will be the equation of the tangent?
Yes, ma'am.
Okay. Why this will be the
Yes,
equation
ma'am.
of the tangent? Because equation of any straight line, as we know, y2 minus y1 divided by x2 minus x1 gives us the slope. Okay. Now the point about this thing comes, x-intercept comes. That is, x-intercept is defined as the point of x when the value of y is 0, right? So only when you are equating that y, only when you are equating y equal to 0, you will be able to get that point of x that is going to give you the next iterative value, and when this iteration goes on and on, you finally converge at the root. Okay, so if you go ahead and see, so now because you are trying to find the x-intercept, only because of that you are able to set the y value to 0. Okay, now, since your y value is set at 0, you rearrange this particular equation and you write it as x2 is equal to x1 minus f of x1 divided by f dash of x1. Okay, so this is the functional form of Newton Raphson, and you will get it in every book. Okay, but what I want you to understand is that both of you unmute and tell me what you think is happening at this point, x4. Why is x4 the root, and what do you think is happening at this point? I want you to give me an understanding of this functional form of Newton Raphson that is there in every book, and we use the formula to find out the answer. But I want you to understand this formula and relate to the graph and give me an idea why and what is happening when you have finally converged at the root. Any of you would like to go first? Try. We have already crossed. Yeah.
Ma'am, we, we can say that we are finding the means real root exact root by
Okay.
iteration method.
Okay, fine. The
Means
understanding is completely good.
the
Yeah. Tell me.
value is been changing, and after at the last we are getting a fixed one value which is the correct root.
Right.
I think so.
Right. Your completely understanding is correct, and you're going towards the correct answer only. Anything else you would like to add? So, what I'm basically asking you is that can you relate this equation? Can you see this equation in the graph? Just try and see. I'll help you also here. Okay. Suppose x2. Just start with this x2. I can see in the graph it is this point. Okay, now x1 also I can see in graph it is this point. Okay, so you will basically merge at the root. Imagine x4 is the root, like from the graph we can see that almost x4 has merged to the root, right? Imagine x4 is the root. So why x4 will be the root, or let's not take x4, let's take x5. Okay, because x5 will be here only, almost here only it will be x5. Okay, now why will we say x5 is the root? Because when it is x5 here is equal to x4 here minus this value, what is happening to this value is what I want you guys to see from the graph. Why is x5 the root? That is what we are trying to find out here. Okay, x5 is the root because a very small value is being subtracted from x4, and hence they have remained the same. Remained the same to an extent that they have merged at the root and they are the same value basically. Okay, so can any of you just try and show me this part? Show me this part in the graph. What a luck. Show me this part in the graph. This part. Can you guys try? Once again, then now I will explain if you can't, but can you guys try? It's just visual, there is no calculation here, it's just seeing and understanding the curve, that's it. Any idea, Tejal? I should end, the other TA will be waiting. Yeah, any idea? No problem, I'll tell you guys. Okay, you guys are there, right, with me? Tejal and Gilesh, both?
Yes, ma'am.
Yes, ma'am.
Yeah,
Unable
okay.
to guess the
Tell me.
answer.
Tell me.
Explain this, ma'am.
Yeah, tell me. Are you saying something, Gilesh?
I was unable to guess this
Okay, very good. No problem.
answer.
I'll tell you what is happening. So first, let's understand the question that I'm trying to ask you. I'm trying to ask you that this is my functional form. This is the functional form of Newton Raphson, and this is the graphical interpretation of Newton Raphson. Okay, what our aim here is to see this functional form and to relate to the graph and understand that yes, this functional form gives us the answer finally when it converges to the root. Okay, this is our question. Have you both understood this part when I explained that why x5 will be the root? Because the previous iteration does not change when this value of f of x1, f of x divided by f dash of x, this value has become very small at this root. And hence this value does not change, and hence f of x5 is the root. Have you understood this concept? You've understood?
Yes, ma'am.
Both of you? Now, the only thing we have to do is concentrate on this part of the equation. Okay? Come to the root, both of you. I'm zooming in here and try and understand what is happening at this point. What is happening to the value of fx divided by f dash of x. Okay? At this point, you will see that the value of f of x has become 0, because f of x is the y-axis, right? And wherever this graph has cut the y-axis, this value has reduced to 0. Do you both agree?
Yes, ma'am.
And what will be f dash x? Anyone would like to give me an idea? F dash x will be positive, negative, or 0? Just tell me this much. Or not positive, negative, or 0 also. Just tell me whether f dash x will be 0 or it will have some value. Tell me this much.
It will have some value.
Excellent. Why will it have some value, Leelish? I will tell you. Because, see, if this is the function f dash x, if this is the function f dash x, only at this point, when it is when this tangent is parallel to the x-axis, only at this point f dash x is equal to 0, right? Only at this point the slope of this function is 0. The function is neither increasing nor decreasing, only at this point. Apart from this, at every point wherever you draw the tangent, you will get some value for f dash x, right? So this denominator has some value and the numerator is 0. So in this functional form, you will see when you arrive at the root, when you arrive at the root, probably f of x5, when you arrive at the root, the previous value x4 does not change, because you're basically subtracting a 0 from it, because the f dash fx is the function which is cutting the x-axis at that point, and hence it is 0 divided by some small value. Okay, some value, basically small does not matter, 0 divided by anything will be 0, and hence it has converged to the root. So have you both understood the concept of Newton Raphson? And how is Newton Raphson giving the root?
Yes, ma'am.
Okay.
Yes, ma'am.
Comfortably? Any confusion how you used to think about it previously and how you think about it now? Any idea, any clarification you would like to give? Both of you have understood, right? That's fine. No problem. So what I will, you've understood, right? I mean, just tell me if there is any confusion. You can tell, speak up, Leelish, no problem. Tejal, both of you.
No doubt, ma'am.
No doubt, understood. Leelish, you are comfortable?
Yes, ma'am.
Okay, so now what I will do is, there is no time to explain the multivariable Newton Raphson, and this was the question which was given in the assignment. Do you both have any doubt with respect to the question given or the multivariable concept? Any doubts? Any of you? Tell me, I couldn't hear you, Tejal.
Yes, ma'am. It was little confusing to understand.
The multivariable Newton Raphson. Okay, so what I will do is, now since the time is over, after the recording you join Rohit's class. I will make a separate tutorial only on multivariable Newton Raphson, go through the algorithm and the example and upload it on YouTube. Okay, you both can just see from it and solve the assignment, and write in the doubt forum if you still have any doubts. Okay.
Okay, ma'am. Thank you.
Okay, chalo. Welcome both of you, and see you guys next Saturday at the same time, 3 o'clock. Okay.